Hello, Assalamualaikum. These are the solution of question from textbook, page 64 to 65, self-exercise 2.11. Okay, the first one, a wire of length 80 centimeter is bent to form a sector POQ of a circle with center O. Okay, so here we have a few clue here. Sector, okay, circle, center O. So then we draw a sector. Okay, sector. O is center. So this one is PQ. OQ is R. Okay, OP R as well because radius are same. Okay, then angles POQ is theta. Okay, so given here a wire of length 80 centimeter bent to form a sector, meaning that 80 centimeter is a perimeter. Okay, so perimeter. Okay, let's say P equals to, we add all. Okay, so R plus, okay. This one is length of arc. Okay, we have formula S equals to R theta. So then the perimeter for arc R theta, okay, equals to 80. So then we simplify, we get to R plus R theta equals to 80. Okay, so we just leave for a while. So here we have to show the area. Okay, show the first one, area of the sector, you have to show equals to 1 over 2R, 80 minus 2R. So now in topic of circular measure, we have formula area of sector is 1 over 2R squared theta. Okay, so then here we can see we have two unknowns, okay, R and theta. So therefore you have to substitute theta. Okay, so let me move this one first. Okay, so for the from the first equation, you make theta is subject to a formula. So R theta equals to 80 minus 2R. So theta equals to 80 minus 2R over R. Okay, this one the first equation. This one the second equation. So then we substitute 1 into 2. Okay, so here we have A equals to 1 over 2R squared. 80 minus 2R over R. Okay, then we can simplify this, become 1 over 2R, 80 minus 2R. Okay, so now we already shown, okay, the formula of area. So shown. Okay, so for the next question, okay, the same question but 1B. Okay, then find the maximum area of the sector. Okay, maximum. The clue is maximum area. Okay, we have learned previously when we want to find the maximum or minimum. Okay, so you have to differentiate and make it equals to 0 and equal to 0. So here we have A. We have A equals to 1 over 2R, 80 minus 2R. So then we expand, we get 40 R minus R squared. Okay, so then we differentiate A in terms of R, we get dA dr, okay, equals to 40 minus 2R equals to 0. Then we get R equals to 20. So then the question asks you to find the maximum area. This one is radius that make area is maximum. So you have to substitute R equals to 20 into A. Okay, so into formula. Okay, into the given formula. So area maximum equals to 1 over 2, 20, 80 minus 2, R. Okay, oh sorry, R is 20. We substitute R equals to 20. Okay, this one 80 minus 40. Okay, we get 400. Okay, so we can test this one is correct or not the maximum area. So we differentiate another time. We get d squared A dr squared. Okay, is -2. -2 is less than 0. Okay, less than 0. So then maximum. So this one, so proven that area is maximum. Number 2, a piece of wire of length 240 centimeter is bent to make a shape as shown in the diagram on the right. Okay, express y in terms of x. A piece of wire of length 240, same, meaning that 240 is a perimeter. Okay, so perimeter equals to 240. So to find perimeter, just add all sides. Okay, here we have 13x plus 13x plus 2y plus 24x equals to 240. Then we simplify, we get 2y plus 50x equals to 240. So then we can all divide by 2. Y equals to y plus 25x equals to 120. So therefore y equals to 120 minus 25x. Okay, so now we already express y in terms of x. Okay, for the next question, to be, show that the area enclosed by the wire is given A equals to 880x minus 540x squared. Okay, so now we have to find the area. Okay, to find the area, you have to construct, let's say here, the horizontal line. Okay, this one PQ is 24 x. Okay, meaning that TR 24 x centimeter as well. Okay, so here is 13. So let me draw again, redraw. Okay, redraw. This is R T S. Okay, so we draw the vertical line. Okay, this one 13x, this one 13x. TR is 24, meaning that 12x, 12x. So by using Pythagoras theorem, the height is 5x. Okay, so then to find the area, okay, area of this shape is A equals to triangle plus the rectangle. Okay, formula of triangle is 1/2 times base times height. Okay, so 1/2, base is 24x, height is 5x, plus rectangle is 24xy. Okay, so then we from question A we have y. Okay, y is this one. Okay, so we substitute. Okay, 1 into 2. 1 into 2. Okay, so this one 12. Here area is 60x squared plus 24xy is 120 minus 25x. Okay, so we simplify, we get 60x squared plus 288x minus 600x squared. So this one 2880. Okay, 0x. Okay, so then we get 2880x minus 540x squared. Okay, so same. Okay, so therefore shown. Then to C, find the values of x and y for A to be maximum. Okay, so the word maximum. So then you have to differentiate and equate to 0. So now we have A maximum. So A from B is 2880x minus 540x squared. So A maximum, so differentiate A. We get dA dx equals to 2880 minus 1080 x equals to 0. So then x is 2 over 3. Okay, so this is the value of x. So the question asks you to find y as well. So we substitute y previously in from 2a. Okay, from 2a we have this one. Okay, y equals to 120 minus 25x. So we substitute y is 120 minus 25x. So we substitute x is 2 over 3. So we get 53 1 over 3. Okay, so then C2. This one C1. Okay, C2. The maximum area enclosed by the wire in centimeters squared. Okay, these two, actually these two values and x and y make area maximum. So the maximum area we substitute into A. So 2880 2 over 3 minus 540 2 over 3 squared. Okay, so then equals to 3840 centimeter squared. Now question number 3. A factory produces cylindrical closed containers for drinks. Each container has a volume of 32 pi centimeter cube. The cost of a material used to make the top and bottom covers of the container is 2 cents per centimeter squared, while the cost of the materials to make the curved surface is 1 cent per centimeter squared. Okay, so now we looks like this one is a hot question. So better we draw first the cylindrical container. So here we have cylinder. Okay, so volume. Okay, so volume of cylinder is pi r squared h equals to 32 pi. Okay, so we can simplify here. We have r squared h equals to 32. Okay, this one is the first information we can get from the question. Okay, the cost of the material used to make the top and the bottom. Okay, for the top we have shape of circle, so pi r squared. The bottom as well circle. Okay, the curve area is 2 pi r h. Okay, for these two, top and bottom. Okay, so top and bottom area. Okay, equals to 2 pi r squared times 2 cent. Okay, so 2 cent equals to 4 pi r squared. Okay, for the curve area, okay, area is 2 pi RH times 1 cent. Okay, so this one is 2 pi RH. Okay, so the cost of all surface area, so cost we have to total. Okay, cos C equals to 4 pi r squared plus 2 pi r h. Okay, so now for this equation, we can see we have two unknowns, which are r and h. Okay, but previously we already have the first equation here, r and h, so we can make h as subject. Okay, so h equals to 32 over r squared. Okay, this one is equation 1. This one equation 2. So 1 into 2, we get C equals to 4 pi r squared plus 2 pi r 32 over r squared. Okay, so here we have 4 pi r squared plus 64 pi over r. Okay, so shown. Okay, so shown same. So shown. Then 3B, you have to find the dimensions, okay, of each container produced in order for the cost to be minimum. Okay, so to be minimum, the word is minimum, so we have to differentiate and equate to 0. Same. Okay, so for B, we have C equals to 4 pi r squared plus 64 pi r power of -1. So then we differentiate C in terms of r. So we differentiate, we get dc dr equals to 8 pi r minus 64 pi r power of -2. Okay, so equals to 0. So 8 pi r minus 64 pi over r squared equals to 0. So 8 pi r equals to 64 pi over r squared. R squared is 64 pi over 80 pi. Okay, so r cube 8. Okay, so cube okay, r cube equals to 8, then r equals to 2. Okay, so the question asks you to find the dimension. Okay, so r is the radius, so radius r equals to 2. So another dimension is height. Okay, so the height, previously height is 32. This one okay, this one 32 over r squared. Okay, so h equals to 32 over r squared. So 32 over 2 squared equals to 8. Okay, so the height is 8. Actually, we can prove the cost is minimum. Okay, so then from the previous one, this one, dc dr, so differentiate another time. D squared c dr squared become 80 pi plus 1 to 8 pi r power of -3. So 8 pi plus 1 to 8 pi over r cube. 88 pi plus 1 to 8 pi over 2 cube. Okay, this one is 24 pi. 24 pi is more than 0, so we get minimum. Okay.